Now we will discuss a more sophisticated way to choose the canonical form in order to achieve the following. As we have said, the canonical triangle may be of this kind of form, where we do not have a control of the number of elements of the chart that appear before we have this discrepancy. However, by a kind of a choice of this canonical form, we will have a control of certain parameters of these regions that we call the domino regions, because they are produced by the domino form. So, and this control will be very useful in the more difficult, in more complicated situations, for example, for Bernstein groups, for angular groups, etc. So, I'm now returning to the choice of the canonical form. Now assume we have more constants, say also lambda 2 and lambda 3, under the same conditions that the difference between is large in the terms of epsilon. And of course, it is much bigger than 1/2. So, what we're doing now? So, the canonical form will be chosen by a three-step procedure. The first step was as before. We take semi, in this case lambda 1, semi canonical form of elements. So this is exactly before. It is defined by a list of forbidden words. Our forbidden words are every relators which this measure is bigger than lambda 1. This is just before. Now, the second will be a new element which actually was here but implicitly here. We'll make it implicit. It is the certified form. And the third, this will be the canonical form. So, what means the certified form? We proceed as follows. First, let us choose some sequence of the numbers 2 and 3, 2, 2, 3, 2, 3, 3. For example, we might require that this is aperiodic sequence. So no word appears subword. It does not contain squares, non-proper squares. So, or some other choice, doesn't matter. We have some, for example, aperiodic sequence in the case of angle groups. We take something that is incompatible with the angle structure, etc. So this is some sequence. So that is called lambda 1 is 2, lambda 2 is 2, lambda 3 is 3, lambda 4 is 2, lambda 5 is 3, etc. We have fixed such sequence. Actually, we may choose it as properly at will, but in view of further use, we may think of it as a aperiodic sequence. Now, when we have a word which is semi-canonical. So we have its R chart. Okay. Now, for each of the elements of the chart, we have some procedure of certification. It may pass it, and it may not pass it. What means this? How can I, what is the procedure? I would like to certify this member of the chart. What is required? There should be, in order to certify a certain element of the R chart, one needs a witness. What is a witness? It may be another word representing the same element of the group there in the same one-layer map. So here should be on the same side. In other parts, maybe not. So I'm looking on the chart of the witness. So the R chart of the witness have certain places, mostly corresponding to the chart of the original, but there may be discrepancy between short words. Some may be above the tau threshold, some may be below the tau threshold, but actually all these that are much bigger than the threshold appearing on both of them. So just as the two sides of the, or the same side of the one-layer diagram. So I'm looking on these members of the chart of the witness. So this is, it should be a witness. A witness. Now, what are the requirements? That we require that, well, actually it was 3, I could take 1 and 2, even better. 1 and 2, easier. This is second. So, what I'm requiring, that this part here will be, its measure will be less or equal than lambda 3. Lambda 3, because this is a stricter condition, because it should be bounded by this one, not by lambda 1. It is a bigger set of forbidden words. Now, both of the next side should be less or equal. If this is 2, it's lambda 2. Actually, lambda 2 is lambda L1, because L1 is 2. The next should be less or equal L lambda 2, L2. Lambda L2, it may be 1, etc. Next, lambda L3, lambda L4, etc. is this according to our choice of this sequence. So, and the same is symmetrically on the other side. So, the requirements are different, they vary. The next one should satisfy this with lambda 2, the next one with lambda 2, then with lambda 1, etc., according to this sequence. So, if such a thing, if such witness satisfying all these requirements satisfies, then we say that after all these, the member of the chart is verified, certified. If there exists a witness, if a given member element of the R chart, there exists a witness satisfying all these conditions, then this member element of the R chart is certified. A word is certified if all of the elements of its R chart are certified. So definition, we call W certified if all elements of its R chart are certified. I mean that for each of them exists a witness who is subject to all these conditions, but of course the witnesses might be different from various elements of the R chart. So each of them needs a witness. If we are able to point out the witness for each of them, so this word will be called certified. So this is the second step, that we take the word in the certified form. Now, by the way, it is easy to see that for each element there is at least one word which is certified. I can now see this. So please, we look on the one layer map. And we know that for each cell there is at least one side that has the length no more than 1/2 plus 2 epsilon. Because for example, assume that this is this side. Then, according to this definition, this will be certified. Why? Because we know that 1/2 is much less than all of this. Then we can take this word itself is a witness of all of its elements of the chart simultaneously. For such a word, the word itself is a witness for all elements of the object. Because all these are much less than these requirements. So this is an easy way to certify it. But the problem starting when we are on the border, it would be something between lambda 1 and lambda 2, and then we have a problem. Maybe it will be certified. It have to stand in the long queue and to wait for the decision of the authorized procedure to declare him certified or not. In any case. Okay. So this is the second step. Now, let me stress that this second step depends on the word globally. Because here, if we add or delete one letter, the result should maybe different, just for the same reasons that I give an example in the beginning. Because then, but what we will see that this difference may happen only we also have this kind of domino falling, then it may actually one letter should influence all of this. But now, the first was local, because we had a list of forbidden words. Then if we see this in any, assume for example that we have of certain lengths, if we see that throughout the word we meet no forbidden words, so it is semi-canonical. So this first is maybe local, but it's nature. The second is a global procedure, and the third will be also a local procedure. So what we do now in the third? So now we can take the certified one-layer map. So we just take all the words that in the certified form, and they are passes in the original one-layer map. So we take all of them. So we say we have the kind of all of them span the certified one-layer map. It means that for each side there is some word, some certified word that goes through this part of it. This what is different. This is by definition the certified one-layer map.
How much is it different from the one-layer map with
all
witnesses?
Because sorry?
If you put the one-layer map that consists of all witnesses, how much is different?
No, because here the witnesses, the requirements is between the switch between lambda 1 and lambda 2. But this that they certify are always near lambda 3. So this is much stronger. So the witnesses may leave the certified one-layer map because their requirement is quicker. But they live in the original one-layer map, but not in this certified, maybe not. In any case. So now we look only this certified map. And then we also take the same kind of a competition that we have used to define the canonical form in the simplest case. So we look at two neighbors that survive the certification. If they do not, then just the absent, but assume they do, then we look on all these possibilities to go to the 16 ways back and forth. So we have here 16 words, and we choose the shortest one according to the word lex competition between them. So, and then it leaves on one of them because we do not have squares, proper squares. So this finally will give us some of the sides, independently from each one. And then when we take this pass, this is, as we say, the pass of the winners of the competition, but now inside the certified one-layer map, so this is declared to be the canonical form. So this is three-step procedure, semi-canonical, just is a forbidden word, certification procedure, looks strange, but there is certain reason to define it this way. Of course, our input is a certain non-periodic sequence. So maybe avoid certain more, maybe also avoid some more complicated patterns. Just it is, we can take anything here. But once we have chosen it, we need to take only witnesses that satisfy this condition. Okay. Now,
could you just repeat why? I didn't understand why there is always a certified.
oh, because all these are much above 100. When I take it as a regional layer map, I know that the sum of all this should be 1. Think, for example, as lambda 1 as 0.8. Then this will be 0.2 plus minus 2 epsilon. So it's much smaller. So we just, if we take the shortest side, there is always it is the shortest side. In the worst case, it is 1/2 plus 2 epsilon, usually even less than this. So if we take the shortest side, then it by far satisfies all the requirements for a witness. Because here it is safe, this is safe for 0.8, 0.9, 0.7, 0.6. So it is just the quick key goes without problems. The problems begin when it is on the boundary of something. Only then we have to look at this. Maybe, yes, maybe. So this is easy. Now, so we have this certified form. From the certified here, we have a competition the same way. It is a local because we take only one on one side, one on the other side, and we define whether there is who is the winner of this competition. The path of the winners will be our canonical form. Okay, now how does this influence this canonical triangle? So now having this way to choose the canonical form, we are asking what will happen to the canonical triangle, the triangle of canonical words. One word, the other word, and their product. In general, there will be the same idea. We will see that there could be at most 4 discrepancies. And we have to see what happens here. This is in this domino form region, because the discrepancy can happen because it is on the boundary, and then we add one letter, it is good, we distract when it is bad, so, but this is because it is precisely inside these boundaries. So what actually happens here? We compare this word that goes this way, one color, and that goes the other way here. Now, when so first we look on the semi-canonical form of both of them. This is easy. So until this point, now they look on the certified form. Now the certified form. So and then assume that finally we have a discrepancy when taking the canonical form. So how the discrepancy can occur at all? So in any case, that just when we look in the certified for the green word and for the blue word, they may have to take different decisions. So on one side there should be, for example, this winner, on other side will be this winner. Now, because this is also comparison by length, and we have to assume that the length is tightly connected with a measure, not necessarily proportional, but tightly connected, then we know that so this will be more or less 1/2 by the length. Otherwise, something that happens on the end of it would not have any effect. So these are close to the half. So both of them are close to the half. Otherwise, it could not be switching sides in this competition. So therefore, it means that this will be certified in both of them. Because we can choose, for example, the short part one, for example, this will be no more than 1/2. And we can choose the short side for the other, also here in some way no more than 1/2. And here they will be the same. Now, what happens that in order, so what I'm saying further, now I know that everything that is before this, the result of the certification for this one and the other one will be the same. This is important. How do I know it? Because assume that we have here some element of the graph that is certified for the green one. So we have a certain witness that certifies, for example, this side. Whatever it does, it satisfies all these conditions. It is a witness for this side. Now, whatever side it goes here, we can make a surgery. So we will, from this point and further, go to this blue. Now, what we know, these are more or less not much than half equals to epsilon, so this will be easy to satisfy. Here we have, from this is close to 1/2, maybe the original witness was on this side, and we switch the side because both of them are close to 1/2. So it may be a little bigger, but it will not destroy the conditions, because the conditions are much easier than 1/2. So when we reach this agent, so we can switch the sides. To switch the sides. To produce a witness for the other branch. When the witness for this branch, And here is a place where we may switch the side and go this way, and vice versa. So it means from this on, we have the same certified one layer map. And then the decisions who is the winner will be just the same decisions. Now, here we might have a discrepancy for the reasons that we assumed. So what happens here? If we have here this domino, so how can this happen? This domino, for example, will mean, so these are, oh, just a moment. So when we look, what is the next one? This something like 1/2 and 1/2, and this because it switches sides. Because when in the final competition it switches sides. Then this is a way to produce a discrepancy. We have one winner for one branch and another winner for the other branch. Now, what could be the next cell? The next cell must have different outcome for the certification step. Because if there would be the same outcome in both of them, or just one of them for both of the branches, then the outcome of this competition will be the same of the branches. Therefore, the next one should be certified for one branch and not certified to another branch. So, it is certified, so it has a certain weakness. For example, this one has this, for this we have a weakness. Now it goes, for example, so this is, for example, the weakness that certifies this one. It goes, in some way it goes, I don't know. But it satisfies all the conditions that the weakness should satisfy. It means that this be less or equal lambda 3. And for the rest, it should be less or equal lambda L1, less or equal lambda L2, etc. These are a priori consequences. Now, on the other hand, now, if what will happen if this will be just much less than lambda 3? Then we could switch the side to the sure place. Because if we reach this, which is the smaller half, then we can go without problems. So why does it happen? Because something was exceeded. It means that when we took this, it will be bigger than lambda 3. So it means, but which is bigger? It means this length, it was here, plus some epsilon was bigger than lambda 3, and lambda itself was less or equal than lambda 3. So it means that the lambda is less than lambda 3 and bigger than lambda 3 minus epsilon. It should be, this length should be within this boundary. If it would be bigger than this, it's not a weakness. But if it is much less, then we can reach in one step the safe haven and go here, be certified. So it should be in this. Now, okay, it happened. Now look on the next one. The next one, we have the same kind of inequality. This it will be between lambda L1 and more than lambda L1 minus epsilon. For the same reason, because if it will be less because it is certified, and if it be much less, then we can reach the safe haven and continue, etc. It means that all these values inside this R chart of this witness are strictly bounded between the cell and lambda L2, lambda L2 minus epsilon, etc., etc. So they have to take some strict values because we assume that these are far away, so they are in a certain intervals. Now, what happens now? Of course, the next step will be to take the shortest side. Because all of these are much bigger than 1/2, and clear the vectors will not be. So it means that we will have just on the other, everything here will be on the other side. Here also, but then it means that all these numbers will be just close to 1 minus lambda 3, 1 minus lambda L1, 1 minus lambda L2. So within 3 epsilon doesn't matter. So it means that in the result we map here, these members of the R chart are subject to strong restrictions. Let me write this down. So it means the following. On this branch, when we encounter a discrepancy in the final outcome of the canonical world, then the next one should be between 1 minus lambda 3 plus minus certain epsilon, and the second 1 minus lambda L1 plus minus certain epsilon, etc., 1 minus lambda L2, etc., etc., until we reach the middle Lk, and then also it goes to different ways. So it means, so the final outcome of it, that we know that this domino area have very strict requirements. What we do not know, okay, the number of these members of the chart may be non-limited, but they should follow this sequence. How it is being applied in the various problems. For example, if this word itself will be a periodic word, then this aperiodic sequence must be inside one period. Whatever the number of k, it must be, so we know actually why we are not able to have a control of the length of it, but if this is a periodic word, it should be inside one period. And then we have a control in the term of the numbers of periods. This is exactly what we need when we address with this technique the periodic groups. For example, if we address the angle groups, then we take a sequence that could not, incompatible with the pattern of the angle group. For example, this is 2 periods, 10 B periods. It must be within 10 B periods because 2 words, so each of the periods has a positive or negative power. So we call them D periods. It should be upon the choice of the sequence inside 10 B periods of angle world. etc. This is why we choose this sequence. We are able to gain the control of how far this discrepancy is from the dominant, from the center. So this explains why this apparently bizarre choice of the definition, but here it imposes a structure that we will need in further. So actually this is one, we describe how we choose the canonical form. It also in more complicated equations, the one is a semi-canonical defined in the number of a set of forbidden words. Then the certification uses witnesses with some conditions imposed on the witnesses. Each of the elements of the chart should have a witness, then the word is certified, and then we take the one layer certified map or one layer certified triangle, and we define finally the canonical word, taking a local competition, and then the best one. Actually, we take the word next for convenience. Any other competition with defined outcome we do. So this is, and then we have this triangle of canonical words, which we actually have proven it cannot have more than 4 discrepancies on its sides. And also we have a control in a certain case of its dominant area. So this is so far for today.